All right, welcome to this explainer. Today, we're tackling a massive topic, literally. We're breaking down the complex, high-stakes world of sourcing heavy-duty wreckers. Specifically, we're looking at 40 to 60-ton rotators straight out of China. Look, if you're making a capital-intensive decision that's going to dictate your fleet's recovery capabilities and safety for the next decade, you aren't exactly adding this to your Amazon cart, right? You need a real anatomy-to-action breakdown, and that is exactly what we're going to do right now. So today, we're basically building your ultimate recovery vehicle from the ground up. Here's our roadmap. We'll start with the shift in heavy-duty recovery, move into core engineering and hydraulics, and then look at selecting the right chassis. From there, we'll map out the OEM customization workflow, logistics, and quality control before wrapping the whole thing up with your essential pre-RFQ checklist. Let's get to it. Section 1. The heavy-duty recovery shift. Redefining high-tier recovery. Okay. First things first, we need to shift our mindset a bit. Professional fleet managers, you guys know this. You aren't just out there buying standard tow trucks anymore. You're hunting for elite, integrated 40 to 60-ton recovery systems. We're talking about machines that can handle extreme environments, everything from clearing out multi-lane highway wrecks to intense off-road industrial extractions. So what actually puts a wrecker in that elite tier? Well, it comes down to the rotator. The rotator is the industry-standard 360-degree continuous rotation system. This right here is what separates high-tier heavy-duty recovery from your everyday standard towing operations. When we talk about hitting those 40 to 60-ton capabilities, this continuous rotation is the absolute baseline we're evaluating. Let's look at a real-world scenario to really illustrate why this matters. Imagine a massive highway pileup. A standard fixed boom wrecker, it has to be positioned directly in line with the casualty. That means you are blocking multiple lanes of traffic just to set up and get to work. It's a nightmare. But a 50-ton rotator, it just pulls up, parks parallel to the incident, sitting safely in a single lane, and literally swings the boom over the side to do the heavy lifting. This drastically reduces your time to clear. And as we all know, time to clear is the ultimate KPI that wins those lucrative government towing contracts and boosts your bottom line. Moving right along to Section 2, Core Engineering and Hydraulics, the muscle and nerves. If we look at this equipment anatomically, think of the boom as the pure heavy metal muscle of the truck, and the hydraulic system as the incredibly sensitive nervous system controlling it all. Now, what's really interesting here is the sheer leap in engineering when you compare a casual 30-ton standard wrecker directly against a 50-ton rotator titan. Just look at the chassis difference. You're moving from a standard 3-axle setup up to a massive 4- or 5-axle foundation. The boom itself evolves from a simple 2-stage telescopic design into this 3- to 4-stage hexagonal beast. And those winches, they jump from dual 15-ton up to dual 25-ton capacities. Because at this level, you aren't just towing broken down buses anymore. You are recovering dropped cranes and uprighting overturned semi-trucks. Let's zoom in on the physics of that boom and winch setup for a second. The boom is the primary point of failure if it isn't engineered absolutely perfectly. It requires high tensile strength steel. Typically, you'll see HG70 or an equivalent used here. This gives you an incredible strength-to-weight ratio, which maximizes your lift without completely destroying the vehicle's center of gravity. You pair that high-tensile steel with dual 20-ton or 25-ton planetary winches, and suddenly you have the brute pulling power required for uprighting heavy machinery and doing it safely. But here's the catch. All that muscle is completely useless without control. Hydraulic integrity is everything. You absolutely need multi-wave valve blocks, specifically imported brands or high-end domestic equivalents, like the Hydro Control or Rexroth standards. These ensure that under maximum load, the movement is precise and totally non-jittery. Because let me tell you, a jittery boom during a high-stakes crane recovery doesn't just look unprofessional, it is incredibly dangerous. Plus, it costs you serious money in downtime. With proper maintenance, strict oil changes and regular seal inspections, these high-quality hydraulic systems are designed to give you a solid 10 to 15-year operational lifespan. But I want to give you a quick reality check, perfectly captured in this quote. A heavy-duty wrecker truck is only as reliable as the legs it stands on. Basically, all the fancy hydraulics and high-tensile steel in the world won't matter one bit if your foundation isn't right. And that brings us to Section 3. Selecting the right chassis, global compliance, and performance. When you're ordering for international markets, your chassis choice is quite literally the very first gate in your entire procurement workflow. It dictates your operational success across different global terrains. For instance, if you are operating out in Africa, Southeast Asia, or the Middle East, Sinotruck is often the go-to because of its robust axle loads and really widespread parts availability. Now, if you're doing extreme off-road or construction recovery, Shackman provides incredible heavy-duty frame reinforcement. And for tight urban environments where you really need maneuverability and lower engine noise, Dongfeng or Isuzu models manufactured in China are heavily favored. But listen, no matter what brand you go with, your critical first check must always be verifying your local emission standards. You have to make sure you're compliant, whether that ranges from Euro 2 all the way up to Euro 6. Okay, Section 4, the OEM customization workflow, tailoring the Titan. In the B2B special vehicle sector, a one-size-fits-all approach is pretty much a fast track to failure. Transactional success means tailoring the machine to your exact regional safety codes and your specific operational habits. So, the manufacturer workflow generally follows a pretty strict 1-2-3 sequence. First up is the technical consultation. This is pure engineering, defining your maximum lift at full extension, which directly dictates your counterweight requirements and exactly how wide your stabilizer outriggers need to spread. Second, we have the toolbox and body layout. Heavy recovery requires immense rigging, right? Chains, snatch blocks, air tools, the whole shebang. So you customize your sidebox layouts, your LED beacons, and your control interfaces, like adding wireless remotes to keep your operators safely out of the danger zone. And finally, the process shifts from paper to manufacturing reality with rigorous stability testing. When we talk about stability testing, there is literally only one number you need to care about: 125%. Before that truck ever ships, the absolute gold standard is an overload test at 125% capacity. They push the boom and the underlift to maximum extension under this immense load. Why? To verify structural integrity and ensure the hydraulic pressure relief valves are perfectly calibrated. It is totally non-negotiable for safety. All right, let's move into Section 5, logistics and quality control, delivery and inspection. Once the truck is finally built, you transition into the execution phase. This involves dealing with the harsh calendar realities of transnational shipping and making absolutely sure the million-dollar asset you paid for is exactly what arrives at your port. Let's look at the timeline realities. From the moment your request for quote is initiated, you're typically looking at about 30 to 60 days for a standard configuration. But if you need high customization or, say, a right-hand drive chassis, expect that lead time to push closer to 90 days. And keep in mind, while the minimum order quantity is usually just one unit, shipping a massive asset like this via Ro-Ro or flat rack is incredibly expensive. Freight optimization has to be calculated into your cost per unit literally from day one. And think about it, after waiting 90 days and paying an absolute fortune in freight, you simply cannot afford a defective asset. You must mandate a third-party inspection from organizations like SGS or 2V. They'll go in and perform a weld penetration analysis to ensure the boom meets ISO standards. They will conduct rigorous hydraulic leak tests. They'll even verify paint thickness, which honestly sounds pretty minor until you operate in a high-salt coastal environment and your massive investment starts rusting out in year 2. Finally, Section 6, your pre-RFQ checklist, transactional readiness. If you are a professional fleet manager watching this right now, here is your final actionable takeaway to ensure you are totally prepared before you ever engage a manufacturer. Keep this checklist handy. First, know the precise max towing capacity of the loads you intend to lift. Second, clarify your left or right-hand drive requirements immediately. Third, clearly define your operating environment. This is a big one because extreme high altitude, tropical, or sub-zero conditions actually dictate the specific type of hydraulic oil the manufacturer needs to use in your build. And lastly, have your regional certification requirements ready to go, whether that's CE for Europe or DOT compliance for the Americas. But wait, before you send off that RFQ, you need to understand one absolutely crucial technical reality: underlift physics. Remember that capacity is rated dynamically. A 50-ton class truck will lift roughly 16 to 20 tons when the underlift is fully retracted. But physics dictates that as that extension increases, leverage kicks in and causes that lift capacity to taper off. So knowing exactly how far you need to reach is just as important as knowing how much you need to lift. So, I want to leave you with this provocative question as we wrap up today's explainer. Will your next heavy-duty recovery fleet arrive fully built, or will you use the SKD, semi-knockdown approach? The SKD strategy is fascinating. It involves having the manufacturer ship just the subframe, the boom, and the hydraulics. This allows you to mount this high-tech Chinese recovery body onto a local chassis, like a Volvo or a Scania, right in your own backyard. It saves massively on import duties and guarantees local chassis serviceability. It is a brilliant way to assemble a global hybrid and completely dominate your local market. The choice and the engineering is entirely in your hands. Thanks for joining me today, and keep building smarter.